Okay, so today guys we're going through 2DL1. Now, I think the textbook does a really poor job of ordering how we should best learn graphing quadratics. And so you'll notice today we're doing a bit from 2D1 and a bit from 2D3 and selected questions. And that's because I'm going to break it down into skills, particular skills, rather than it being about completing the exercise. So today we're doing what's called graphing from axes-intercept form. So when we're graphing a quadratic, it has the shape, Mace, of what we call a parabola. Parabola, no, we say parabola. And that means it's going to be like sort of opening up. It's like a hill, right? It's like an inverted hill, can be opening upwards or opening downwards. And I want to talk about the key properties, right, of the parabola. These are, firstly, the roots. Now, what do we call them? We call them roots, x-intercepts, or zeros. All right, they all mean the same thing. And that is where the function crosses the x-axis. Now, the important thing to note about these, okay? The x-intercepts, the roots, occur when the y value is 0. When y is 0, that's when our roots occur. Okay? Similarly, we have a y-intercept. That's where it crosses the y-axis. What do we notice about that point? X is 0. So we have y-intercept when x is 0, x-intercept when y is 0. We're going to be using that today for the graph. The other property we have of a quadratic is what we call a vertex or a turning point. And that's like a local min or max. That's where it sort of comes down and reaches its furthermost point. All right? The vertex is always halfway between the roots, okay? Such that it's symmetric. That's the same distance. All right? So we're going to be using all of those properties today. Now that is why in the first example, I want us to change it, rather than being x plus 2, I want it to be x plus 1, so that I can exaggerate the axis of symmetry. I can exaggerate where the vertex is occurring. Okay, so for us to graph it, we're going to identify the x-intercepts and the y-intercepts, and then we're just going to plot that. That's all we are going to do to graph the quadratics. So, I'm going to make a fairly sort of long, elongated argument. You can shorten it as you become more competent and comfortable with it. Firstly, x-intercepts. X-intercepts occur when y is 0. All right, the x-intercepts occur when y is 0. So all I'm doing is I'm going to put the number 0 where the y is. We would have x plus 1 times x take 3 equals 0. And we know how to solve this. We're going to apply the null factor law. X plus 1 is 0, or x take 3 is 0. X equals 1, or x equals positive 3. That is where it crosses the x-axis. Okay, so to graph it, we need the x-intercept and the y-intercept. Let's find the y-intercept. Y-intercept when x is 0. So if we put x is 0 into our equation here, we have 0 plus 1 is 1, 0 take 3 is minus 3, and 1 times minus 3 is minus 3. The y-intercept is minus 3. We have everything we need to plot it on a graph. All right, so to start with, I'm just going to sketch a plane, and I haven't provided a grid for you there, so we're just going to do a rough sketch to begin with. And as we get further into these two exercises, we're going to be more particular about the shape and so forth that it takes. So firstly, the roots are x is minus 1. So I'm going to put that there. That's minus 1. That's one of the roots. And the other root is positive 3. So we've got 1, 2, 3. That's my other root. Okay. I have a y-intercept of minus 3. So we can put it anywhere. I'm going to put it here. I'm going to say that's minus 3, minus 6, minus 9. All right. This is where it's crossing the y-axis. Okay, so far I'm colouring those points in. I'm saying it has to pass through those points and it has to be a parabola. It has to have this shape, right? And so because it has to pass through those points, it's going to have a shape like this, right? It's going to be like that. Now, one other thing that we're going to increase in being particular about as we go through it is the location of the vertex, right? The more we do it, we're going to get more precise about where this turning point occurs. For now, it just needs to be approximately halfway between the roots, right? So if you think that distance there is from -1 to +3, that's 4 units. And so halfway between them, half of 4 is 2, so it needs to be 2 units from that root and 2 units from that root. So it's about there, okay? We're demonstrating that this point is halfway between those two, okay? We don't know how far down it goes. We can determine that a bit later on, but for now, I just want us to get the general shape correct. Okay, so what do? We find the x-intercepts, we find the y-intercepts, we plot them, and we draw a curve through it. Okay, next one. -2 times x plus 1 times 3x take 2. So first, let's find the x-intercepts. Y is 0. Now this -2 out the front is actually going to have no impact on the roots because remember we can do anything as long as we do it to both sides. We're going to divide both sides by -2. Okay, so if I divide both sides by -2, here's what I'm doing. We're going to be left with here, that's going to cancel. X plus 1 times 3x take 2 equals, well 0 divided by -2 is just 0. Okay, we'll apply the null factor law. X plus 1 is 0, or 3x take 2 is 0. Okay, so just solving those linear equations. So find the x-intercepts, find the y-intercept. Y-intercept when x is 0, so that's going to be you're putting 0 where the x is. And so when you do that, right, like over here and in this example, I've plugged the 0 in, but basically that x term, you don't even need to think about it, all right? What it evaluates to is just this number. It's just the number that remains. So it's -2 times 1 times -2. That's going to be +4. The y-intercept is +4. All right, so when it comes to sketching this one, we have the roots -1 and 2/3. So if we just do it approximately, -1, here's +1, and 2/3 means 2/3 of the way to 1, right? So it's going to be about there, 2 and 3. That's my root, that's my root. My y-intercept is +4, so we'll put that here. Okay, and the vertex is halfway between them, right? And so it's going to be like just here. It's just a little bit closer to that root. So we'll sketch a curve through those points, just roughly, just trying to get it right. Okay, so this time the quadratic's facing downwards, right? But it still has that parabolic shape. Okay, any issues if I rub out the first one and sketch up our graph? Okay, so what we're doing there is here, we're going from the equation to a graph, right? What we're going to do in our next example, in question 2, is we're starting with a graph and we're going to figure out the equation from the graph. So we've got -3, +1, +3. minus 3, positive 1, positive 3, x and y. So here's the graph I've presented for question 2. Now, what we can see from the graph, right, is the x-intercepts, the roots, are 1 and minus 3. Now, remember, I don't want to make it too complex. Let's just go straight to this. This form here, a times x take p times x take q, this is the linear factor form of a quadratic, okay? And this is what's going to pop up a bit later for us when we look at the different ways of presenting quadratics. This is one way of presenting it, where p and q are the x-intercepts. Well, our x-intercepts, our roots, are 1 and minus 3. It doesn't matter which one's p, it doesn't matter which one's q, it's going to come out in the same. So all I'm doing, I'm just going to say 1 is p and minus 3 is q, and I'm going to take both of them and put them into this form here. Alright, so we will have y equals a times x take 1. I'm just putting 1 where the p is, and then times x take minus 3. Need to carry the negative with it. Alright, so always x take p, x take q. Q is negative 3, so x take negative 3. We will simplify that. Okay? And then we need to determine this value of a. We need to say, what is this value of a? Because a is the dilation factor, right? And so to determine a, we need to use some other piece of information. We've used that, we put them in. What are we left with? This one. We're left with this point. And what is this point? Well, when x is 0, x is 0 at that point, y is 3. So we're going to plug that in here. So I'm putting 3 where the y is, and I'll put 0 where the x is. So I've got 3 equals minus 3a. The only value of a that makes this true is minus 1. You can obtain that by dividing both sides by minus 3, right? It'll cancel there. 3 divided by minus 3 is minus 1. Which means the equation of this quadratic, the equation of this graph is like this. But we don't need the 1, okay? If I put this just negative out the front, that means minus 1 lot of it, all right? Whenever we have 1 lot of something in algebra, we don't need to write the 1, we just write the term of which we have 1 lot of. And so this is the answer, right? Therefore, the equation of this quadratic is what we've found here. So there we did the opposite, right? We started with the roots and we put them into linear factor form, and then we put another piece of information. It could be a y-intercept, could be a point on a graph, doesn't really matter. And we put that in. So we break this down into 2 skills. We're going to start graphing from axis-intercept form, okay, hopefully pretty okay. And then we're going to look at, from general form, how we can manipulate the quadratic into axis-intercept form in order to graph. All right, so let's have a go at the first exercise there. So I've written down 2D.1, question 1 and 3. That's the first part that I do want us to have a bit of an attempt at.